sequences in series. Now I want to start by deriving our situation. So let us say, for example, that we have some sequence. I want to show you a pattern that develops. Let's continue with our basic sequence of 1, 2, 3, 5, 6, 7. Okay. And then I want to let I'm getting it in. A1 equal 1, A2 equal 2, A3 equal 3, so on and so forth. A7 equals 7. Okay. I want to show you a pattern that's developing. Right? Recall I showed you that 2 is equal to 1 plus our common difference here, which is 1. Okay. So D is 1. So if I was to rewrite this in symbolism, I could say A2 equals A1 plus the common difference. Okay, so I could also say, and we can call that 3 is of course 2 plus 1. So A3 is equal to A2 plus D. So on and so forth for the rest of them. Okay. Now, we see A2 is equal to A1 plus D. So what I can do is switch them or substitute them, and I could say A sub 3 is going to be A sub 1 plus D plus D. This forms kind of a pattern, so to speak, which A sub 3 ends up being A1 plus twice D. Our difference between them. Because 1 plus 1 is 2. And this pattern ends up repeating itself. Like, let's say I did this for A4. Right? Is of course A3 plus our D. A3 is A1 plus twice D. Which is A1 plus 3D. And I want you to notice something. That the subscript 4 and the number that's next to D, coefficient 1 less than that. So we actually have a pattern that forms. And this pattern is what we use to find the nth term of a sequence. Okay. So this pattern, I'll write it down in a different color. And the definition of an nth term of a sequence. So A sub n is going to equal the first term plus n minus 1 times D. Okay. This equation can also be written, there's your book. Your book gives it as also a form of a linear equation. A sub n is equal to dn plus c. and it's reality just the same equation. C is equal to A1 minus D. It's the same equations I just showed you, but you can write it either in terms of a linear equation or in terms of this formula, this recursive formula that we defined it to be here. So these are two important formulas to memorize, and we can use them to find any number of a term in a sequence. It doesn't matter, as long as I don't even have to have the first term. I can just use these to find the terms of the sequence, whatever I want. Okay. So we use this to kind of develop a form for the nth term of a sequence. So let's do an example of that. Okay, here's our example. We're going to develop a formula for the nth term of a sequence. Whose common difference is 3. And the first term is 5. So, we're given D is equal to 3, A sub 1 is equal to 5, right? So if I follow the formula, A sub n equals A sub 1 plus n minus 1 times D, I have the first piece and I have this D piece. So A sub n is equal to 5. 5 plus n minus 1 times D, which is 3. And then I distribute the 3. Five plus 3n minus 3, and then 5 minus 3 is 2. So A sub n is equal to 3n minus 2. Easy enough. Let's do one more example, and then I'll leave you to do one on your own. Develop a formula for the arithmetic sequence whose fifth term is 10, and its third term is 7. Now, you'll notice in this problem, I did not give you the common difference in this situation. And because I did not give you the common difference or the first term, it seems as if you cannot do this problem. But it's still solvable. Okay. So we have a5 is equal to 10, and a sub 3 is equal to 7. Okay. How do we do this problem then? If you do not have either the first term or the common difference to work with, well, you can find them. So I know a sub 5 is equal to a1 plus 5 minus 1 times d. I know a sub 3 is equal to a1 plus 3 minus 1 times d. Which develops a system of equations. Okay. So simplifying all this nests, so we end up with a1 plus 4d is equal to 10. a1 plus twice d is equal to 7. Okay. And if I subtract them, right? So if I subtract these two rows, right, that becomes 0 plus twice d is equal to 3. And if I divide by 2, I end up with our common difference is equal to 3 halves. Okay. From there, we can use that to figure out whatever the first term is. So it doesn't matter which equation I use here. So we'll just use a smaller one. So a3 is equal to a1 plus twice d. a3 is 7. Three halves, that kills that. So we end up with 4 is equal to a sub 1. Thus, we can now develop the formula for the sequence. So then a sub n is equal to a sub 1 plus n minus 1 times d. A sub 1 is 4. D is 3 halves. With the distribution, we end up with 4 plus 3 halves n minus 3 halves. And then 4 minus 3 halves is going to do 5 over 2. So plus 5 divided by 2. And this is our formula for the a sub nth term. So I will leave you, and we will come back and discuss how to do some more things.